In this video, we will learn how to factor the greatest common factor, or GCF. Factoring a number or expression means rewriting it with numbers or expressions that can be multiplied together to produce the original number or expression. When we multiply, we are taking two factors and multiplying them to get a product. When we are factoring, we are looking at the product and determining the factors. In our last chapter, we were given a problem like this: 2 times the quantity x plus 4, and we multiplied the 2 through to get 2x plus 8. In this chapter, we will be given something such as 2x plus 8, and we want to factor it as 2 times the quantity x plus 4. So factoring is the reverse operation of multiplication. To find the greatest common factor of two terms, list all the factors of each term. Choose the largest factor that is common in both terms. When factoring expressions with variables, use the highest power of x common to both terms. Greatest common factoring for polynomials. In order to factor the greatest common factor out of a polynomial, you must first identify the greatest common factor of the terms in the polynomial. Next, we're going to rewrite the polynomial. Divide each term of the polynomial by the greatest common factor. Place the expression in parentheses. Then place the GCF outside in front of the parentheses. Next, simplify the terms in parentheses. Note, the number of terms in the parentheses should be the same as the number of terms in the original polynomial. Check the answer by multiplying the factors using the distributive property. In our first example, we have 3x plus 27. The factors of 3x are 3 and x. So for our term 3x, our factors are 3 and x. For 27, our factors are 3 times 3 times 3. The greatest common factor in both 3x and 27 is 3. So our greatest common factor is the number 3. Then we will divide each of our terms by the greatest common factor. So we get 3 on the outside as our greatest common factor, and then we will simplify our terms. 3 over 3 is equal to 1, and 1 times x is x. 27 divided by 3 is 9. We can check to make sure that we did this correctly by distributing the 3 through the parentheses. Three times x is equal to 3x, and 3 times 9 is equal to 27. So this is the factored form of 3x plus 27. In our next example, I would like to figure out what is the greatest common factor of these two terms. What is the greatest number that divides 16 and 24? That will be our greatest common factor. 4 divides 16 and 24, but also 8 divides 16 and 24. So 8 is the biggest number that divides both 16 and 24, so that is our greatest common factor. Then write parentheses. Then ask yourself, what should we write here that when we multiply it by 8, we get 16x? 8 times 2 is equal to 16, and then we need to get 16x, so we need to multiply by x as well. Then we need to ask ourselves, what should we write here so that when we multiply it by 8, we get negative 24? Well, negative 3 or minus 3. So 8 times negative 3 gives me 24. And we can check this by distributing the 8 through the parentheses and see if we get our original problem back. 8 times 2x is equal to 16x. And 8 times negative 3 is equal to negative 24. In our next problem, we can see that 4 or negative 4 is our greatest common factor. Both terms have a 4 or a negative 4. We could factor out either a 4 or a negative 4, and that would be a factored form of this polynomial. Let's start by factoring out a negative 4 and see what we get. So let's put a negative 4 on the outside of parentheses and then ask ourselves, what should we write here so that when we multiply it by negative 4, we get negative 4x? That would be x. Then let's ask ourselves, what should we write here so that when we multiplied by negative 4, we get negative 4? What times negative 4 is negative 4? Well, that's positive 1. So let's check by multiplying out. Negative 4 times x plus 1. Negative 4 times x is negative 4x. And negative 4 times positive 1 is negative 4. So yes, we get the exact same polynomial when we multiply through. So this is the factored form of negative 4x minus 4. Now, we could have just factored out a 4. So let's write the problem again, negative 4x minus 4. We could have just factored out the number 4. Then what will we have in parentheses? What times 4 is negative 4x? Well, that's negative x. And what should we multiply 4 by to get negative 4? Well, that would be negative 1. Both of these answers would be correct. Example 4 is a little bit different. The greatest common factor for number 4 is not going to come from the coefficients. Notice we have a 1 coefficient in front of the x squared term and a negative 8 in front of the x term. So we will look at our variables. Notice each of these terms have at least one x variable. So our terms and our factors. Let's take a look. For x squared, our factors are x times x. And for 8x, our factors are 2 times 2 times 2 times x. So the factors that both of these terms have are just an x. So let's write the x in front of the parentheses and ask ourselves, what should we write here so that when we multiply by x, we get x squared? What times x is x squared? That would be x. Then we need to figure out what should we write here so that when we multiply by x, we get negative 8x, and that would be negative 8. So this is the factored form of our problem. So let's check this. Let's distribute the x through the parentheses to see what we get. X times x is equal to x squared. And x times negative 8 is equal to negative 8x. In this problem, we have a greatest common factor that is going to have a number other than 1 and an x. Notice we have coefficients of 6 and 30. The greatest common factor of 6 and 30 is going to be 6. So let's write that outside of the parentheses. We also see that both terms contain an x. So let's put that x outside of the parentheses as well. Then we'll ask ourselves, what should we write here so that when we multiply by 6x, we get 6x squared? Well, that would be x in order to get the square on the x when we multiply. Then ask ourselves, what times 6x is going to give us 30x? Well, that would be multiplying by 5. So we get 6x times the quantity x plus 5. Let's check. Multiply 6x through the parentheses. 6x times x is equal to 6x squared. And 6x times 5 is equal to 30x. So this is the correct factored form. Example 6. Let's first look at our coefficients. What is the greatest common factor of 10 and 6? Greatest number that divides both 10 and 6 is the number 2. So let's put that outside the parentheses. Now let's look at our variables. In our first term we have x to the fifth. In our second term we have x squared. When we're talking about the greatest common factor, the power that is the least will be our greatest common factor. So we can take out an x squared in both of these terms. So let's think about writing our terms that we have originally, and we'll do this one by dividing everything in parentheses by the greatest common factor. So outside still is the 2x, which is our greatest common factor, and now let's simplify. 10 divided by 2 is equal to 5, and when we are dividing, we subtract exponents. So 5 minus 2 is equal to 3. So our power on the x is 3. Now let's look at 6 divided by 2 is equal to 3. And then we see we have x squared over x squared, so that divides out and is equal to 1. And 3 times 1 is 3. So this is our factored form. Let's check it. Make sure it's correct. Let's take the 2x squared and distribute it through the parentheses and see if we get our original problem back. 2x squared times 5x to the third. Well, let's multiply the 2 times the 5, the coefficients, and get 10. And x squared times x to the third, we add those exponents and we get x to the fifth. Then we're going to multiply 2x squared times negative 3. 2 times negative 3 is equal to 6, and then we have the x squared. So that gives us back our original problem. So we know our factored form is correct. Now we need to look at 3 different terms and find the greatest common factor in all 3. So let's look at our numbers. In number 7, we have coefficients 10, 4, and 12. What is the greatest number that will divide all 3 of those numbers? That number is 2. So let's put that on the outside of the parentheses. Now let's look at the variables. We have x to the third, x squared, and x. The greatest common factor will always have the least power on the variable, so we can take out just an x out of all 3. Then we will write our polynomial in the parentheses and divide it by the greatest common factor that we have factored out in front of the parentheses. And then we will simplify what's in the parentheses. Our coefficient is 10 divided by 2, which is 5. Notice when we have this x, the power on it is a 1. So we are going to subtract the top exponent 3 minus 1 and get 2. 4 divided by 2 is equal to 2. And again, we're going to subtract the top exponent. 2 minus 1 is 1. And we don't need to write that. And then 12 divided by 2 is 6. And x over x is equal to 1, or you can say it divides out. So that is our factored form. And you can check distributing the 2x through the parentheses will give you back the original problem. Problem 8 is a little bit different. We have some binomials within this problem. I don't want you to distribute and combine like terms. What I want you to do is look at this as one term and this as another term. It's not really a term, but think of it as a term. Do you see that both of these have the quantity x plus 1 as a factor? So what I want you to see is that this is similar to this problem, 6x p minus 7p. Now if we were going to factor this, we would notice that both terms have a p in them. And we could factor the p out, and we're left with 6x minus 7. I want you to view this x plus 1 as what we just called p. So let's factor out the x plus 1 out of both terms. And what we're left with is 6x minus 7. So we factored out x plus 1 out of these two terms, and we're left with 6x minus 7.